Hey physicists, this is the big workout, an example energy topic challenge by me. And take a look at a little cardio workout and some strength training. Hey, the equipment I'm going to be using today will be horizontal bench press. Chose that because in the classroom, besides picking up a few pieces of test equipment and an occasional whiteboard marker, don't get a chance to work out that much there, and the elliptical trainer sitting around the classroom doesn't get a chance for the heart to work out much. So thought those would be good uses of my time. Here we have 40 pounds of weight. One, 3, 4, 5. I want to figure out the distance. I lifted that weight. I'm extending my arm here, and now you can see from my shoulder to the my hand about 58 centimeters.
Hey, we're going to take a look. Okay. Hey, we're going to take a look at the total amount of work and the power required during one lift here. Hey, so I'll go through the 5-step process. Step 1, draw a picture. Pretty poor one, but you can see me pushing on that bar. 2, what are we trying to find? We're trying to find the work in 5 lifts and the power in 1 lift. 3, what are we given? Hey, we know that the force is 40 pounds. The distance I pushed it was 0.58 meters. The time for 1 rep was 1.1 seconds. Total was 5 reps. Anything else needed? Hey, we also know that 1 pound is equal to 4.5 newtons. Both units of force, but 1 pound is equal to 4.5 newtons. Okay, 4, let's take a look at our relationships here. Hey, we know that work is equal to force times distance, and power is equal to work divided by time. Hey, looks like we're in a pretty good position to solve this. So solve. So work is going to be equal to our force, which is 40 pounds. We want to convert that into newtons. So 4.5 newtons per pound. Those will end up canceling. Times distance, 0.58 meters. Let's go ahead and multiply that out. 40 times 4.5, 180 newtons times 0.58 meters is equal to 104.4 joules. Now we'll multiply that by 5. Those are 5 reps. We get 522 joules of work in the 5 lifts. The other thing that was being asked for was power, and power is work over time. I'm going to use just the work for a single event. This one here, 104.4 joules divided by, and I timed on the video, it looked like it was about 1.1 seconds. A joule per second is a watt. This works out to 94.9 watts. Let me rewrite that here, 94.9 watts. There you got it.
There we go. Up on the end, yeah.
Rachel Ray, yeah. Oh my God,
And cool down time.
Hey, the second one we're going to look at the the total energy put out in joules from the calorie count on the elliptical machine, and then the average power during that cardio session. So let's say we got our picture here, poorly done picture of me on the cardio machine or the elliptical. We want to find, one is going to be our total energy, and the other thing we want to find is the average power, or the power on the machine. Okay, 3 given. Not too much given here. In the video you ended up seeing that total energy, or the energy expended, was 51 calories. That's the food calorie. Sometimes in chemistry you'll call that a kcal. Okay. We also know that there are 4,184 joules in each food calorie. It also took, the time was 5 minutes. So let's look at that relationship. Hey, first thing is our energy in joules is equal to 4,184 joules per calorie multiplied by the energy in calories. And the other one that we have is power is equal to work or energy divided by time. Let's go ahead and put this together and we'll solve this. So 5 is solve. So our energy in joules is going to be equal to 51 calories times 4,184 joules per cal, and put that in the calculator. I get 213,384 joules. So that's my energy in joules. Last one is how much power was I putting out? That's going to be our work, which is also our change in energy, or dissipated energy, divided by time. Our total energy or work was 213,384 joules divided by, hey, our time. Maybe we could add that 1 minute is equal to 60 seconds, so 5 minutes is equal to 300 seconds. So let's go ahead and divide that by 300 seconds. Put that in the calculator. I get 711 watts. Seems a little high for a person to be able to do that, especially I'm wearing a tie while doing that. I have to go back and take a look at the calibration of the machine. Seems a little odd, a little bit higher than what we'd expect when you're reading. You probably saw that normal value would be just a couple hundred watts. But that's what we get right now. We'll have to go back and take a look at the machine to see if there's any issues with its calibration. Alright, good luck.
Hey, so in this simple model, let's take a look where the energy flow comes from and goes to. Hey, so originally we start with, hey, breakfast, Cheerios and milk. That ends up moving its energy into me. I head on over to the fitness center, and that goes into the motion in the elliptical, and eventually the moving air and the heat end up becoming dissipated. So the energy starts with that food energy into me, into the movement of the exercise equipment, eventually gets dissipated into the room.